Hello everyone and welcome to the channel. Image segmentation has come a long way since the advent of generative AI. Image segmentation is the process of dividing an image into smaller parts or regions based on their characteristics such as objects, colors, textures, shape, and a lot of other things. Image segmentation helps computers understand what's in an image, making it useful for object detection, image editing, autonomous vehicles, medical imaging, and for a lot of other use cases. Segment anything models or SAMs have emerged as a transformative approach in image segmentation. They are quite known for its robust zero-shot segmentation capabilities and flexible prompting system. But still, its performance is challenged by images with degraded quality. Addressing this limitation, this new model, Robust Segment Anything model or Robust SAM, has really shown some promises as it enhances SAM's performance on low quality images while preserving its promptability and zero shot generalization. In this video, we are going to install this robust SAM locally and then we will play around with some of the examples. This is a project page which you can see on the screen and I will drop the link to it in video's description. Plus they also have this model available on Hugging Face if you are interested. Before I show you the installation, let me give a huge shout out to Mast Compute who are sponsoring the VM and GPU for this video. If you're looking to rent a GPU on affordable prices, I will drop the link to their website in video description. Plus, I'm also going to give you a coupon code of 50% discount on a range of GPUs. This is a terminal I'm going to use. And this is my GPU card, NVIDIA RTX A6000 with 48 GB of VRAM. Let me create a virtual environment. I'm just calling it SAM with Python 3.11. Let's wait for it to get activated. And that is done. Let me install all the prerequisites, which include torch, transformers, and all that stuff. Let me run it. It is going to take a couple of minutes. Okay, so all the prerequisites are done. Let's clear the screen. Next up, let's git clone the repo. And I'm just seeding into it. The repo is RobustSAM. Next up, let's install all the requirements in this repo. Okay, so I think I haven't, okay, sorry, I just missed the R here. There you go. Okay, so let's wait for it to get installed. It shouldn't take too long. So all the requirements are at last done. Let me clear the screen. Next up, let's download the model. I'm just downloading it with wget from Hugging Face. Let's wait for it to get downloaded. And these models are small. The segment anything model, the SAM models, because they only do one thing, which is segmentation, and that's about it. So let's wait for it to finish. And that is already done. You can also just check it quickly with ls-ltr, and the model is at the top, as you can see, with the PyTorch format. So that is cool. Next up, let me launch my Jupyter notebook and we will run our notebook environment there. And don't worry about the command which I'm going to show you, because I will give you the link to the notebook from the repo, which you can also run as per your choice. So let's wait for it. Our Jupyter notebook is launched. Let me import all of the libraries which we have installed. So libraries have been imported. Next up, let's define these three functions. Now, these are quite standard functions which are drawing the bounding boxes. So for example, this show box, this is drawing the bounding box, as you can see with this B box, whereas this show points is plotting the colored points based on the label with these red, green, white colors. And then this show mask function, it displays masks with customizable colors. And this is primarily used for object detection and segmentation. And that is why we are defining them. So let me run it, and that is done. Next up, let's load the model which we have just downloaded. This file is already present in the working directory. We are putting it on our GPU, and then this is the vision one, and then we are just printing the message here. And you can see that the PyTorch checkpoint of the model is loaded. Okay, so next up, let's get our image. So I'm just going into the demo images which they have given in the repo, and then we are just displaying this blur and then applying the transformation with our SAM model. Let me run it, and there you go. You can see that this is the image. How good is that? Okay, so now let's try to draw a bounding box around this face here. So if you look through the code, we're just giving it an array. We are just declaring that we are going to do the box. We already have defined the function for it, and we are passing image the boxes, and then we are plotting it. So let me run it, and let's scroll down. There you go. You see how good is that and how accurate the box is. Also note down the speed of the model is very impressive, and it has even created a mask around that face of the bug. Okay, next step, I have just used the CLF to clear the excess plots and all the image, because we are going to try a next image, and this from this image, the haze.jpg. Let me show it to you. So let me run it. So you see it's a hazy image, the whole of it. And now try to segment these objects in this hazy image with this robust SAM. And this is the beauty of this robust SAM, that even if the image quality is low, it is able to detect the object and then it is able to segment them. So let's try it out. Let's go there, let's go down. There you go. So how beautifully it has just segmented in this hazy stuff these objects. I have cleared the image again. Let's try out another image. Let me show you the image first. In the low light at the night time. So let's try to segment this. I'm just going to go down, paste the code here. Let's run it. Let's go down. There you go. Even in the low light during the night time, it is able to segment it. I have cleared the image again. In the final example, let me show you an image from the rain, and then we will try to segment this plant, not the stem, I guess, just this one in the rain. So this is the code. Let me run it. Let's come down. There you go. So how beautifully stem too. So it has beautifully segmented it very properly. If you just go up and compare it, even this leaf is just falling down and it has properly segmented it. If you look at this segmented resultant image. So that's it, guys. If you have any more questions or if you want to see more examples in action, you can simply go and check out their project page. They have quite a lot of information around its architecture and a lot of other good stuff. I will drop the link to the notebook in video's description. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thanks for watching.